Very delighted to interact with you again. Now we are into the new chapter called Chemical Kinetics. I think perhaps you are the luckiest batch, it seems, because um, as per the board pattern, you will be compulsorily getting a 5-mark question from Chemical Kinetics, having internal choice with the solution lesson. That is why solution lesson and kinetics lesson, we always emphasize the students to learn very well, because numericals are compulsory and must, correct? And especially this chemical kinetics lesson, theory part very less, even before reduction of the portion or before deletion of the topic, correct? Only problems are more, especially Arrhenius equation, collision theory, and all those things are completely deleted for NCERT students. So you are a very luckiest students, but for NEET and IIT students, I think those portions are not deleted. So it's a must for them. So in the 60% of this chapter, okay, we need to learn a less amount of theory and more amount of problems now. Numericals. Very interesting. Okay. So as usual, I try my level best to keep you engaged with a lot of interest and enthusiasm. Okay, Mama. In spite of that, if you are having any doubt, you WhatsApp me, then I will reply you. Right. Chemical kinetics. Kinetics means movement, motion. Here, what is the meaning of motion? Nothing is moving here like physics. But there, objects perform displacement, movement from one place to other. That is what we call as kinetics. But here, reactants are getting converted to products via intermediate or without intermediate. That study is called kinetics. Actually, chemical kinetics offer, what are the scopes now? Chemical kinetics studies about the speed of the chemical reaction, rate of the chemical reaction, and what are the various parameters that influence the rate of the reaction, such as temperature, concentration of reactant, size of the container, correct? Then temperature of the reaction, pressure, okay, and then presence of catalyst. All those things are to be taken into account while studying kinetics. So before going to kinetics, we need to know certain general terms, correct? In chemical kinetics, we call rate of the reaction, which is exactly equal to speed of the reaction. In physics, we call it as speed. In chemistry, in physics, we call speed or velocity. In chemistry, we call it as rate. Okay, velocity or speed acquires a new name called rate. Correct? What is velocity, Distance traveled divided by time taken. If the distance is meter, time is second, meter per second. If the distance is kilometer and time in hour, kilometer per hour. Correct? So that is velocity or speed in unit of speed or velocity in physics. The same yardstick applies here. Distance traveled divided by time taken. Here no chemicals are traveling any distance. Here the distance traveled indicates the starting point to ending point. So instead of distance, you can say what is rate of the reaction? Change in concentration of either reactant or product, correct? Divided by change in time. So in physics, the velocity is what? Distance traveled. So that term is that statement is replaced by change in concentration of reactant or product divided by change in time. My biggest advantage in chemistry while defining rate, this here I have written my rate of a reaction. Velocity of the reaction, how would you define change in concentration of reactants or products divided by change in time? You can ask me, sir, why you are mentioning reactants or products? Because the speed with which the reactant disappear will be equal to the speed with which the product are formed. Correct? So law of conservation of mass. So that is why we define like this. Change in concentration of reactants or products divided by what? Change in time. This is one thing perhaps you might have studied in 11th. Concentration is always represented in a square bracket. Correct? Concentration is represented by square bracket. That is called molar concentration. Molar concentration means what? Molarity. So in chemical kinetics, the concentration employed is molar concentration or molarity, whose unit is known to you, mole per liter. Molarity unit is what? Mole per liter. Correct? So how would you pronounce this? Concentration of A or molar concentration of A, correct? Then how would you pronounce this? Concentration of B, molar concentration of B. And then what is this? Concentration of C, molar concentration of C, concentration of D, molar concentration of D. Really, I am telling you, you will find chemical kinetics very much interesting, very much interesting, correct? Okay, this is one point I wanted to tell you. Another one, even though in CBSE those units are not employed, but I think it is advisable to learn that kind of. You know very well that 1 liter is equal to 1 cubic decimeter, dm3. You are not supposed to pronounce this as decimeter cube, cubic decimeter. 1 liter is equal to 1 cubic decimeter. Then 1 per liter is equal to 1 dm minus 3. Correct? So these are all the small things I wanted to talk to you. Right? Change is represented by either delta, correct, or small d. Both the versions are accepted. Suppose I want to say, let me tell you the meaning of the following terms. Shall we? What is this? Concentration of A. Correct? What is delta A, my dear beloved students? Change in concentration of A. Correct? The delta. Delta refers to change. And this is concentration of B. Change in concentration of B. Then concentration of C. Change in concentration of C. See the beauty? This can also be written as, this change can be written as dA. This can be written as dB and dC. That small d refers to infinitesimal changes. Capital D refers to mega change. But nowadays, both the versions are accepted. Correct? Infinitesimal change or whatever maybe. Okay. Right. So I hope my beloved students are firm with the thing that I have mentioned. Rate of the reaction, this rate del C divided by del T, change in concentration divided by change in time. This is very important part of the discussion. Unit of rate of the reaction, unit of velocity, meter per second. Correct? Similarly, what is the unit of the rate of the reaction? Numerator, change in concentration. Mole per liter is concentration unit divided by time. Usually seconds, divided by second. So second comes to the numerator, mole per liter per second. Suppose instead of liter, if you write cubic decimeter, mole dm minus 3 divided by second. Mole dm minus 3 per second. All my students know very well that this mole per liter is capital M, molar. So you can also write this as molarity per second. Molarity per second. So this is the unit of rate of reaction. Mole per liter per second, mole per cubic decimeter per second, molarity per second. Correct? So this is, be assured about that. Okay. After that, A gives product. This is reactant, this is product. Correct? You will be asked to write rate of the reaction with respect to reactant, with respect to product. Because you know very well that rate of disappearance of reactant is equal to rate of formation of products. Correct? Rate of disappearance of reactant will be equal to rate of formation of products. Correct? So A gives P. Obviously, what is rate? Forget about this minus and all. Okay, don't come to or free jump to any conclusion. First, always while learning, learn as if you are an innocent person. Correct? Then the learning will be proper. This one I already worked out. Just in your presence, I want to work out. A gives P. Shall I? Okay. A gives P. Rate with respect to reactant, del A divided by delta T equal to. You can ask me, sir, why you are putting equal? Should we not add? Is it not additive? No, ridiculous to say this. Ridiculous to say this. I am equating this with respect to that. Now only I told you, rate of disappearance of reactant will be equal to rate of formation of product. Some of the students they add additive. dA by dt delta A divided by delta T plus delta P by delta T. Correct? Being CBSE guys, kindly don't indulge in this kind of practices. Kindly, please. Okay, understand? Del A by delta T is equal to del P by delta T. Correct? Right. But if you compare this with that, here we have indicated negative sign. Here we have indicated positive sign. Immediately you will be sure that, sir, will rate be negative? We know that rate is positive. Will rate be negative? Here, this symbol, this plus symbol and minus symbol is not implying or inferring the rate of the reaction. This negative symbol, why we are introducing now? We want to tell you that whenever the reaction progresses, whenever the reaction occurs, whenever a reaction proceeds, whenever a reaction happens, okay, so many things we can say. Concentration of reactants keeps on decreasing and the concentration of products keep on increasing. Correct? How do I show that I am expressing the rate of the reaction with respect to reactant, with respect to product? Will you go shut your eyes and do meditation? Correct? In this case, okay, K gives B or some other. In a megamolecular reaction, how do I know this one is reactant and that one is product? So, in order to indicate that the rate of the reaction is expressed with respect to reactant and rate of the reaction is expressed with respect to product, we want to tell that, or we want to know that concentration of reactant keeps on decreasing and the concentration of product keeps on increasing. In order to highlight that, we indicate negative sign for reactant and plus sign for product. We don't have such a thing called a negative rate, positive rate. These signs are not related to rate. This is related to concentration of reactant. This is related to concentration of products. Correct? You need to nip the bud of suspicion or doubt in the bud. Correct? You need to nip it in the bud itself. Correct? So that is why we are mentioning that. With respect to reactant, with respect to product. Next, A plus B gives C plus D. I think directly I can work out. These two are reactant, these two are product. Correct? Each reactant contribute and each product contributes towards the rate of the reaction. So they are not additive. So the speed with which these two disappear will be equal to the speed which these two will form. Then every individual reactant exercises its own rate. Then it is not additive. Correct? Individual reaction. Actually, a class consists of 40 students. Imagine all of them are reactant. So they are heading towards exam to form products now. I think the rate of the reaction, the rate of thinking, the clinical speed of thinking will not be same for everyone, but they ultimately will go to the destination. Same is the case. Correct? Right. Now, with respect to A, what do you write? Minus delta A by delta D is equal to minus delta V by delta D is equal to plus delta C by delta T is equal to plus delta D by delta T. Correct? Here, number of moles 1, 1, 1, 1. Generally, not in this video. After solving couple of problems, I will tell you one secret. Okay, even if you fail to remind me, I will definitely divulge that secret. What is that? Suppose here we are having x mole of A, y moles of B, m moles of C, n moles of, or even if possible, I will divulge. They are all number of moles. Correct? So, whenever you want to express rate of the reaction with respect to number of moles, the number of moles should be brought to the denominator. Correct? See, for example, x mole of A minus number of moles x 1 by x. Correct? Delta A by delta T is equal to minus 1 by y delta B by delta T is equal to plus 1 by m delta D by delta T is equal to plus 1 by n delta D by delta T. The number of moles should be brought to the denominator. Then only the speed will be made uniform. Correct? Suppose instead of that, if you multiply this one, speed will be multiplied with the same speed, these two will not be formed. Suppose if you are dividing correct? this speed and this speed will be averaged to the number of moles of products. I hope you understand. That is why we have to divide the stoichiometric coefficients. Correct? I think by doing some problems you will understand this much better. Okay, even I will give you more explanation in the successive videos. Okay, now let us do some of the live examples of method of expressing rate of reaction. First one, N2 plus 3H2 gives 2NH3. For this, you need to write rate of the reaction with respect to reactant and product. Kanna, I tell you one thing. Chemical reactions are following law of conservation of mass. Amount of reactant destroyed must be equal to amount of product formed. So remember, you cannot write rate of the reaction with respect to reactant and product unless you are given with balanced equation. Suppose you are given skeleton equation, you are given an unbalanced equation. If you are asked to write rate of the reaction with respect to reactant and product, you should express your inability to write. Sorry, for the given reaction, rate cannot be expressed because the given reaction is not stoichiometric. The given reaction is a skeleton reaction. The given reaction is not a balanced reaction. That is the answer. Then board will definitely appreciate. Correct? There are certain questions for which you cannot give an affirmative reply. You cannot give a positive reply. Correct? If the question is erroneous. Correct? So, for erroneous question, what is the best way to answer now? You have to spot out the error. That is called comprehension. Correct? Don't think that I am boring you much. What I want to say is, whenever you are given any chemical reaction, you are asked to write rate of the reaction with respect to reactant and product. Now, first and foremost thing that should occur to your mind is check whether the reaction is balanced or not. Now, let us take 2 nitrogen, 3 into 2, 6 hydrogen, 2 into 3, 6 hydrogen. Obviously, for the given reaction, it is stoichiometric, balanced. I can write the rate. Correct? So, what is rate of the reaction? Rate is equal to, here 1 mole. Don't be over smart. Minus 1 by 1. Correct? Don't do that. So, minus delta N2 divided by delta T is equal to, this is 3 So, minus 1 by 3 delta H2 divided by delta T is equal to plus 1 by 2 delta NH3 divided by delta T. You will be given full mark. Correct? Next, one more example. Shall we? Okay, I think you are understanding this much better. Okay, 2SO2 plus O2 gives 2SO3. For this reaction, you need to write rate with respect to reactant and product. What will you do? Will you start immediately? No, you have to check. 2 sulfur, 2 sulfur. 2 into 4, 2 into 2, 4, 4 plus 2, 6 oxygen. 2 into 3, 6 oxygen. So, be happy that the given equation is balanced equation. So, what is rate? Rate is equal to minus 1 by 2 delta SO2 divided by delta T is equal to minus, don't say 1 by 1, minus delta O2 divided by delta T is equal to plus 1 by 2 delta SO3 divided by delta T. Correct? I hope you understand. N2, 3H2, 2NH3. This is 1 by 1, but it is 1 by 3. This is 1 by 2. Correct? Next, 2 more examples now. 2 more examples. Okay, all are, I think I am not asking anything from extra, only textual examples now. Shall we do? I am ready. First, H2 plus Br2, you get 2HBr. I think the equation is self-balanced. 2 hydrogen, 2 hydrogen, 2 Br, 2 Br. Equation is balanced. So, rate is equal to, with respect to hydrogen, with respect to bromine, with respect to minus delta H2 divided by delta T minus delta Br2 divided by delta T plus 1 by 2 delta HBr divided by delta T. Correct? Next, one more equation. PCl5 dissociates to give PCl3 plus Cl2. What is the speciality of this equation? Self-balanced. See, 1 phosphorus, 1 phosphorus, 5 chlorine, 3 plus 2, 5 chlorine. So, rate is minus delta and PCl5 divided by delta T is equal to plus delta PCl3 divided by delta T plus delta Cl2 divided by delta T. Correct? Okay, Kanna. See the heading. Rate law or rate equation. And all my beloved students must sharpen your comprehension. You must brighten your idea regarding this rate law rate equation. It is so easy, at the same time it is little bit misleading. So I try my level best to give you all possible explanations as far as rate law or rate equation is concerned. The root or basis of rate law or rate equation is law of mass action, which you have studied in your 11th month. Law of mass action. That is the base. Correct? But at this juncture, I want to tell you one thing, that rate law or rate equation is an experimental quantity. Experimental quantity, which is very important. Rate law or rate equation is an experimental quantity. It means what? You cannot predict from theory. Theoretically, rate law or rate equation cannot be predicted. Always you understand one thing. It doesn't mean the theory is wrong. Correct? There should be some theory. Correct? Indirect application of theory is practical. Indirect application of theory is practical experience. I hope you understand. You cannot shun theory or you cannot avoid theory so as to come for practical experience. It's highly futile. Correct? Rate law or rate equation, again I am telling you, my dear beloved students, is having its grounding on law of mass action, which is theoretical. But in practice, rate law for any reaction, rate expression for any reaction, rate equation for any reaction should be written only by performing experiment. That is why I am telling rate law is an experimental quantity. Correct? Again, you may have some doubt. For example, I tell you one thing. You take any two-wheeler or high-powered vehicle, two-wheeler or four-wheeler. In the speedometer, they will indicate 240, 300, etc., etc. Okay, it means what? That speed is attainable. Correct? In practice, I hope you understand, you cannot. Okay, what is being achieved in practice is called experimental. For foolish argument's sake, you can say, sir, I can drive at 300 direct on the road or direct to heaven. What nonsense. Correct? That is the limit. 300 or 220 is the limit. The speedometer. Immediately after fastening with the seat belt, informing everybody that I would like to start with the top speed. 220, I think everybody will reach a top speed only. We can say that 220 or 240, whatever it is, it depends upon the high powered vehicle. It means what? That is attainable, but in practice are you able to attain? Practically I am telling you, you may have so many flowing thoughts in your mind, but you cannot drag all the thoughts and put it in a paper in the form of statements. No? Highly impossible, highly impossible. Correct? That is theory, ma. This is practical. See, it may be a boredom for you. Why sir is giving this much explanation? In the online mode, in the offline mode, many of the students they approach, sir, everything we understood, rate law understood, rate expression understood, but you are saying it is experimental quantity. There we have some doubts, sir. Na, ma, theory we want, but in practice, what is the original rate law? That we have to find out. That is why I am telling you, rate law is an experimental quantity. Rate equation is an experimental quantity. Correct? Right. Now, here I have given 1, 2, 3, 5 reactions. A gives product. That is 1 molar A gives product. Here A plus B gives product. 2A gives product. 3A gives product. 2A plus B gives product. Correct? This is stoichiometry. 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 What do you understand by the term called stoichiometry, my dear beloved students? 1 mole of A will give 1 mole of B. 1 mole of A combines with 1 mole of B to give only 1 mole of product. See the anomaly? This is called stoichiometry. And here, 2 moles of A give 1 mole of product. 3 mole of A gives 1 mole of product. Correct? 2 mole of A combined with 1 mole of B to give 1 mole of product. What is the difference between stoichiometry and speed? Remember, any chemical reaction will obey only stoichiometric pattern. Understand? But speed will not follow stoichiometry. Any chemical reaction should follow only stoichiometric pattern. For example, let me make my point very clear. Ammonia formation. What is ammonia formation? N2 plus 3H2 gives 2NH3. This reaction, how does the reaction occur? Compulsorily, 1 mole of nitrogen must combine with 3 mole of hydrogen to form 2 mole of ammonia. That is stoichiometry. There is no change in the stoichiometry. 1 mole of nitrogen must combine with 3 mole of hydrogen. This is stoichiometry. This is upper layer. Correct? External layer. Any chemical reaction always occurs stoichiometrically. No doubt, no second thought. But in that reaction, speed of the reaction will be governed by any one of the reactant or both the reactant, or sometimes the speed will not be governed by none of the reactants. I think it will surprise you much. Again I am telling you, this particular reaction, why I am taking this example now? Because it's a familiar example. I think you have acquaintance, you have familiarity, so that I am giving you a familiar example. Now again I am telling you, stoichiometry will always be obeyed in any chemical reaction. Stoichiometry will be always obeyed, no doubt about it. 1 mole of nitrogen must combine with 3 mole of hydrogen to form 2 mole of ammonia. That is stoichiometry. No change. But the speed of the reaction will be influenced by whom? Whether it is nitrogen or whether it is hydrogen. I hope you understand. That is why rate of the reaction is an experimental quantity. 2 reactants may participate. Nitrogen, some of the students they ask, sir, how one will influence the rate, sir? In a bus, only driver will influence the rate of the bus. Correct? Everybody, all passengers will go and stand behind the steering wheel and accelerating, clutching, nothing. What nonsense. Only one person decides the fate of so many passengers. Same is the case in the reaction also. You may have multiple reactants, but any one of the reactant or both the reactants, in some cases, there are certain reactions where reactants concentration will not influence the speed. You take large quantity of reactant, smaller quantity of reaction, the rate of the reaction is same. Correct? That is why I am telling you, rate law, rate equation cannot be predicted. See in the stoichiometry. If you are really understanding this concept now, I am partly successful now. every year we find it a little bit not difficult to inculcate the golden idea into the mind of our students. Remember, if anybody questions you, hey, seeing the stoichiometry, will you predict rate of the reaction? Yes. Your answer is bush. No, you are not supposed to say this. No, sir. No, madam. Seeing the stoichiometry, rate of the reaction cannot be predicted. Why? Because rate of the reaction is an experimental quantity. Then they will ask you, then why stoichiometric equation is given? Immediately your reply is always stoichiometra. Metra na measure. Stoichio, fixed measure. Everything takes place in the universe, only fixed measure. That particular reaction, okay, takes up so many mole of this reactant and so many mole of with another reactant to form fixed mole of products. So the given reaction always follows stoichiometric pattern, but speed may be influenced by all the reactants, or speed may be influenced by one of the reactants, or speed will not be influenced by none of the reactants. Then you will be respected more by everybody. Oh, what this tender age, this boy or a girl having very good understanding about the kinetics. Correct? But many of the, why I am giving this much explanation now, I think as we are interacting with many students, that experience I am just sharing with you. That's all. Okay, so stoichiometry of the reaction we need to carry out the. So we come to a conclusion that stoichiometry is needed to carry out the reaction, but not determining speed of the reaction. Correct? Right. So this is explanation part of rate law, because always remember rate law is an experimental quantity, rate expression is an experimental quantity. It cannot be predicted on seeing the balanced equation. If my beloved students understand this much concept now, really I will be extraordinarily happy. Correct? Right. But the rate, what is it? Law of mass action. In 11th we have studied law of mass action. Theoretical, proposed by two scientists, namely Gullberg and Watch. That is theory. They say, rate of the reaction is directly proportional to molar concentration of reactants whose stoichiometric coefficients are raised to the respective concentration. This is general theory. It's like saying, hey, when you study well, you will get good marks. Law of mass action is like that. Sometimes, we study day in and day out. We may not get good marks. Okay, see, that is where we all believe Almighty and luck, destiny, blessings of Guru, blessings of elders, blessings of seniors, etc. Sometimes it happens, some of the students who start preparation towards the fag end of the academic year, almost tail end we can say. Hardly 4 months they prepare. Some students right from childhood, correct? Always writing in the book, from LKG onwards, 12th topper, I should be 12th topper. I came across some students, up to 11th, they do not know what book they possess. But 12th end, fag end. See, I am comparing law of mass action here. Law of mass action says rate of a chemical reaction is directly proportional to molar concentration of reactant whose stoichiometric coefficient raised to the respective power. This is generalized statement. This is, see, here I have written all the expressions based on law of mass action. That is theory. In practice, I may study an essay. I may study 100 chemical equation. On the paper, will it be possible for me to write everything without any mistake? That is experimental. Correct? This is general study now. If you study well, you will get good marks. I accept. What are the other parameters? Experimental parameters. What correct topics you should study, how much hours you should study, what are the reference books you must follow, correct ancillary questions we have. Same is the case. See, many of the students, they get confused by simply studying law of mass action. Rate of the chemical reaction is directly proportional to molar concentration of reactants whose stoichiometric coefficients are raised to the power n. I tell you, A gives product, am I right? According to law of mass action, rate is directly proportional to concentration of A. Here one more mark, 1. I want to remove proportionality constant, so I introduce a constant called K. Rate is equal to K into A. This expression is called rate law. What is rate law? Basically, what is rate law? Rate law is an expression relating rate of the reaction, concentration of reactant. And what is the name of the constant K now? That constant K is called rate constant, velocity constant, speed constant. Why you call K as rate constant now? Because that occurs in rate equation. Correct? Theoretical rate equation. I have to modify my terms. Theoretical rate equation, whatever it is. Correct? So, 1 mark or 2 mark definition. What is rate law? Sir, is it there in the textbook? You write own statement. Rate law is an expression relating rate of the reaction, rate constant, and the concentration of reactant. Enough. This is basic. This is basic. Correct? Then A plus B gives product. According to law of mass action, I am telling you, according to law of mass action, rate is directly proportional to A concentration into B concentration, power 1, rate is equal to K into A. Correct? Then 2A gives product. According to law of mass action, rate is directly proportional to A power 2. Rate is equal to K into A power 2. Right. 3A gives product. Rate is A power 3. Rate is equal to K into A power 3. Correct? 2A plus B gives product. Rate A power 2, B power 1. Rate is equal to K into A power 2B. Right. Remember, theoretical. Correct? You can ask me. You said rate law is an experimental quantity. How should we verify that rate law is experimental quantity? A valid question. Because for the past few minutes, I have been simply, blabbering or shouting about rate law is an experimental quantity, rate equation is experimental quantity, but we write theoretically based on law of mass action. We have to justify. How will you justify? Wait. Suppose if this equation holds good, now, I raise the concentration of A by 2 times, make it 2 times. Automatically, if the rate increases by 2 times now, then this equation is correct. Correct? I hope you understand. This is how you have to explain. This is called experimentally determining rate law. Remember, in a reaction, several reactants may participate. All of them stoichiometrically participate, but all of them need not kinetically participate. Understand the difference. In a chemical reaction, all the reactants stoichiometrically participate, but kinetically they need not participate. Kinetically means what? They are involved in the determination of velocity. See the term. Stoichiometrically participate, no doubt about it, because the reaction occurs stoichiometrically. But kinetically, will they participate? Kinetically means what? Whether all the reactants will determine speed or anyone will determine speed. Correct? That is why, again I am telling you, rate is an experimental quantity. Okay. Next one. This one. R is equal to K into A into B. Imagine, I increase the concentration of A by 2 times now. Rate should increase by how many times? 2 times. Okay. I increase the concentration of B by 2 times now. So, this is 2, this is 2. Rate must be increased by how many times now? 4. Am I right? But imagine, let us increase the concentration of A 2 times. Concentration of B 2 times. But the rate enhanced only 2-fold. Enhanced by 2-fold now. I come to a conclusion that either A or B will not contribute towards the speed of the reaction. Hence, this law is not correct. Correct? Imagine, we understand that B doesn't contribute for rate of the reaction. So, we have to write modified rate law. What is the modified rate law now? R dash is equal to K dash into A. Why we are excluding B? Because experimentally it is determined that B will not influence rate of the reaction. Now you tell me, rate law is what quantity? Experimental quantity. Next, R is equal to K into A power 2. We accept this as valid when increase the concentration of A by 2 times ma. When you increase 2 times, 2 power 2, how much? 4. If the rate of the reaction increases by 4 times, then I accept this. Increase the concentration of A by 3 times, then 3 power 2, 3 into 3, 9. If the rate increases by 9 times, then this equation is correct. Suppose I increase the concentration of A by 2 times. Rate increases only by 2 times. Again, my dear beloved students, watch very carefully. I am talking this case. Concentration of A is increased by 2 times. Rate increases only by 2 times now. Then, what is the modified law? What is the modified law? The modified law is R is equal to K into A, not A2. Correct? This is theoretical. This is experimental. So, whenever you are given, if you can ask, sir, then what about one more A, 2A? Again I am telling you, 2A stoichiometrically participate, but 1A kinetically participate. Correct? Understand the difference. Then, similarly, here R is equal to K into A power 3. When will you say this is a correct expression? As per the stoichiometry, suppose you increase the concentration of A by 2 times 1, make it 2 power 3, 2 into 2 into 2, how much? 8. Suppose increasing the concentration of A by 2 times, if the rate is 8 times, then we accept. We increase the concentration of A by 2 times. The rate increase only by 4 times for this reaction. What is the reduced rate lamma? R is equal to K into A power 2. A power 2. So, this is very important part of our kinetic studies. Correct? Again I am telling you, rate law or rate expression is an experimental quantity. Number of reactants stoichiometrically, but any of the reactants kinetically. Okay, well, so I think I gave you the elaborate discussion. Watch the video again. In spite of that, if you are having any doubt, please message me, ma. Awaiting your messages. Thanks for watching. Thank you.